Arithmetic sequence. Arithmetic sequence is a sequence in which the difference between two consecutive terms is constant. Just like for this example, the sequence 4, 7, 10, 13, and 16. The difference between 4 and 7 is 3. Between 7 and 10 is 3. 10 and 13 is 3. 13 and 16 is also 3. 3 is called the common difference. Therefore, a sequence is arithmetic if it has a common difference. And to find the common difference, subtract the preceding term from the previous term. Consider these sequences. Identify whether the sequences are arithmetic or not. For sequence A, 9, 4, -1, -6, -11, and so on, is an arithmetic sequence with a common difference -5. For sequence B, 1, 3 halves, 2, 5 halves, 3, and so on, is an arithmetic sequence with a common difference 1/2. And for the sequence C, 7, 15, 23, 31, 39 is also an arithmetic sequence with a common difference 8. And for sequence D, 1, 3, 6, 10, 15 is not an arithmetic sequence because it has no common difference. Let's go back with the first example. 4, 7, 10, 13, 16. In this sequence, 4 denotes a sub 1, 7 denotes a sub 2, 10 denotes a sub 3, 13 denotes a sub 4, and 16 denotes a sub 5. So in general, we can write an arithmetic sequence like this. A sub 1 is equal to a sub 1. A sub 2 is equal to a sub 1 plus d. A sub 3 is equal to a sub 2 plus d, or just equal to a sub 1 plus d, or just equal to a sub 1 plus 2d. A sub 4 is equal to a sub 3 plus d, is just equal to a sub 1 plus 2d plus d, or just equal to a sub 1 plus 3d. A sub 5 is equal to a sub 4 plus d, or just equal to a sub 1 plus 3d plus d, and just equal to a sub 1 plus 4d, where a sub 1 is the first term and d as a common difference. As noticed, the coefficient of d is 1 less than the subscript of a. Therefore, the formula in finding the nth term of an arithmetic sequence is a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, where a sub n is the nth term, a sub 1 is the first term, n is the term number or the term location, and d is a common difference. Let's apply this formula in the following illustrative examples. For example 1, find the 15th term in the arithmetic sequence 3, 10, 17, and 24. So the one that is asked in the problem is a sub 15, or the 15th term. So for our given, we have a sub 1 is equal to 3, the common difference 7, and n 15. For our solution, we will use the formula in finding the nth term of an arithmetic sequence. A sub n is equal to a sub 1 plus n minus 1 times d. Next is to substitute the given values. A sub 15 is equal to 3, which is the first term, plus 15, the term number, minus 1, times 7, the common difference. Next is to perform the operations. A sub 15 is equal to 3 plus 15 minus 1, which is 14, times 7. A sub 15 is equal to 3 plus 14 times 7, which is 98. And 3 plus 98 is equal to 101. Therefore, the 15th term is 101. How about example number 2? What is n if a sub n is equal to 25 in the sequence 3, 5, 7, 9? Therefore, the one that is added in the problem is n, or the number of terms. For our given, we have a sub n, which is 25, a sub 1, or the first term, which is 3, and the common difference 2. For our solution, we will use again the formula in finding the nth term of an arithmetic sequence. A sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Next step is to substitute the given values. For a sub n, we have 25, a sub 1 is 3, and the common difference 2. So 25 is equal to 3 plus the quantity of n minus 1 times 2. Next is to apply the distributive property. 25 is equal to 3 plus n times 2, which is 2n, and negative 1 times 2 is negative 2. Next is combine like terms. 3 minus 2 is equal to 1, so it will become 25 is equal to 1 plus 2n. Next is add negative 1 to both sides. So 25 minus 1 is equal to 24, and 1 plus 2n minus 1 is equal to 2n. Then divide both sides by 2. 24 divided by 2 is 12, and 2n divided by 2 is n. Therefore, n is 12, or there are 12 terms in the sequence 3, 5, 7, 9, and so on. What if we're asked to find... And for our example 3, find the common difference if a sub 23 is equal to negative 1.77 and a sub 1 is equal to 0.65. For our given, a sub n, or the nth term, is equal to negative 1.77, a sub 1 is equal to 0.65, and n is 23. And for our solution, again, we will use the formula in finding the nth term. A sub n is equal to a sub 1 plus n minus 1 times d. Next is to substitute the given values. Negative 1.77, which is the nth term, is equal to 0.65, the first term, plus the quantity of the term number 23 minus 1 and the common difference d. Next is to perform operations. Negative 1.77 is equal to 0.65 plus 23 minus 1 is 22 times d, then 22d. Next is add both sides by negative 0.65. So negative 1.77 minus 0.65 is equal to 0.65 plus 22d minus 0.65. Then what is left is the 22d. Next step is to divide both sides by 22. So negative 2.42 is equal to 22d. And d, or the common difference, is equal to negative 0.11. Therefore, the common difference is negative 0.11. Thank you for watching. That's all.